Hello, everyone, and welcome to our webinar, Aluminum versus Steel Tooling, a comparison, featuring our speaker, Taylor Foster, Account Executive for the Mid-Atlantic region. Taylor has a background in mechanical engineering and business, attended the University of Kentucky, and has been working in the manufacturing industry, specializing in injection molding consultation and education, as well as customer experience for the past 2 years. This presentation is expected to last approximately 45 minutes and is being recorded. There will be a Q&A session at the end of the presentation, so we ask you to please use the questions field on your screen to submit your questions. Follow Eccentric Mold and Engineering on LinkedIn so that you can stay up to date on our latest blog topics and webinar schedules. Also, follow Taylor, whose contact info is on the screen right now. We will be sending out a recording as well as the presentation within about 48 hours. And now turn it over to Taylor.
Thank you, Mark, and good morning, everyone. Thanks so much for taking some time from your busy schedule this morning to join me. This topic is one that every engineer working in plastic parts has had to consider critically with each project that they bring to market. It's a topic that's been studied, experimented around, and debated for decades. Today, I aim to definitively help you put the debate to bed by using some of those very studies, as well as my personal experience and that of my mentors. On that subject, I do want to start by establishing a bit further my background relative to this topic and discuss bias a bit, as you all must be wondering by now if I'm slanted towards one type of tooling or the other due to what my current company may offer. I've worked for the past 2 years across 2 different manufacturing companies who both offered injection molding and where I specialized in assisting our molding customers. Both my previous company and Eccentric offer aluminum and steel tooling, and I've spent those 2 years consulting on anywhere from 20 to 40 unique molding projects per day. As you can imagine, I've seen plenty of both. Depending on the customer expressed needs, I guided those engineers in the direction that best fit their project, not the direction that best fit myself or my company. I say that to say I'm speaking to you today, not from a self-serving perspective at all, but from a perspective that's focused on helping you make the right decision on your next project. All right, I'm glad to have that off my chest. Let's jump into a little bit of what I've learned. But first, let's get a quick gauge on everyone's current beliefs and understanding about steel and aluminum tooling. So what I'm going to do is I'm going to go ahead and pop up a polling question for us. We are going to be interactive today. So you'll see now on your screen, I've opened the poll. The question here is, which describes your understanding about aluminum and steel tooling? And you can select all of these that apply. So you can check multiple boxes here. The options are, aluminum is only for small volumes. Steel is the best option for moving a project to production. Steel produces a part of superior quality. Steel can produce geometries and parts that aluminum can't. And aluminum can't produce parts as quickly as steel in production. So we're going to leave this open here for a good maybe 10, 15 seconds. We'll see as these votes come trickling in, and then I will close and we will look through the answers. Go ahead and get that vote in. Okay, awesome. We're at about 75% have voted. I'm going to give it about 10 more seconds here, and then I'm going to close the poll. So go ahead and get your votes in here if you have it. Okay, awesome. I'm going to go ahead and close the poll here, and I'm going to share the results. So let's take a look here. Everybody can see here on their screen, we've got about 48% of attendees today feel like aluminum is only for small volumes. Around a third of you feel like the best option for moving a project to production is steel, as well as feeling like steel produces a part of a better quality and that it can produce geometries and parts that aluminum can't. And then for the last item here, you can see about a tenth of us believe that aluminum can't produce parts as quickly as steel in production. So thank you everyone again for sharing your feedback there. I'll go ahead and hide that and we'll hop back into our presentation. So some common beliefs about steel and aluminum tooling. And as you can guess, you've just seen some things relative to exactly this. So again, One of those common beliefs out there is that aluminum tooling is only for small volumes and prototyping. It doesn't work for production. Another is that steel tooling is the best option when looking at moving your project to production. Another is steel produces a part of superior quality, as we've just seen. It can produce geometries and parts that aluminum tooling can't, and that aluminum tooling can't produce parts as quickly as steel tooling in a production setting. Now, one more thing I do want to address here, and we didn't have in our options, but we're going to address right now, is that the location you choose for creating your tooling isn't a factor in which type of tooling that you would be using. So what I want to do now is go ahead and serve up another polling question for us, and it is directly related to that last question, or that last point there. As you can see on your screen now, the question is, where the tooling is created has an impact on what mold material is used, true or false? So this one's a simple one. Hit me with a true or false. Awesome, you guys are flying this time. We're already up at about 75% voted. Give it a couple more seconds here. Awesome, I'm gonna go ahead and close this one up and share the results with everyone. And it looks like about 60% of us right at here on the webinar today feel that that statement is true. Where the tooling is created has an impact on what mold material is used. Okay, we're gonna answer that question here shortly, but one more quick question that I'm curious about before we do that. So let me serve one more quick question here. Let's launch this one. And this one is more specific to you. So where do you, as an organization or as an individual, usually buy your tooling? Is it in the US? Is it in China? Or is it somewhere else? Maybe Europe, India, somewhere like that. And again, thank you all for your interactivity. This makes it so much more fun for me and hopefully a little bit better for you as we walk through this material. All right, we're already at 75% vote here. Give it another 5 seconds and I'll close this one. Awesome. So let's close this one up here and let's show you guys what everyone said. Awesome. So about 46% of folks on the call today typically buy their tooling in the US. Another 37%, maybe a third of us or so, buy our tooling in China most often. And then 18% of us are getting our tooling somewhere else most typically. Thank you guys, that's super helpful, and it's gonna feed, as you can see, right into our next topic here. So let's pop back into our presentation and answer that question. Does it have an impact? Yes, where you tool does matter. Your two major options, as many of you know, are typically gonna be the USA and China. Again, there are some other locations, but for our purposes of comparing aluminum and steel, these are the most relative or relevant, I should say, to the conversation. So the reason for tooling location mattering is that there are vast cost discrepancies in materials between the US and other countries, notably for this discussion between aluminum and steel as raw metals and materials in each of those countries. So in the USA, aluminum is a much cheaper raw material than steel, making it the default choice for most USA toolers. Okay. Overseas, on the other hand, specifically in China, steel is cheaper than aluminum. So the opposite is true, making it the default choice for tooling. So I know, as we've all just seen, there's a good split of where we typically get our tooling quotes and our tooling orders placed. So as you know, you do see in China, typically speaking, a steel tooling quote, and in the US, you're gonna see an aluminum tooling quote. That's just kind of how it is. So if you're quoting tooling in different locations, you're going to be looking at quotes for vastly different tools. That's the bottom line here. And as a result, you need to be able to make a choice on which one's going to best fit your needs and be able to compare apples to apples in a scenario where you're actually looking at apples to oranges in terms of the materials. So before we hop into our next slide here, let's go ahead and serve up another couple of questions to get your opinion on our next topic. So you'll see the question popping up on your screen here. The question now is, what is your typical tooling budget per project when you're creating molds? So is it typically going to be 5,000 or less? Is it typically going to be somewhere between 5,000 and 10,000, somewhere between 10 and 25,000? somewhere between 25 and 50,000 or over $50,000 in terms of your average budget for tooling. Awesome. We're already at about 75% voted here, so thank you again. Give it another 5 or 10 seconds here. Let the last answers trickle in. Awesome. Let's close this one up and share the results with everybody. So here's what we're seeing on our webinar today in terms of our audience and the engineers here. We're looking at about 14% are operating on a pretty small budget for molding for sure. 25% of us, about a quarter, are looking at between $5,000 and $10,000 on average for tooling. The vast majority here, it looks like, has a budget, typically speaking, of between 10 and 25,000. And then some other, obviously, options here that also got some pretty good response, just like 5,000 or less. So you can see where the spread is here on typical tooling budgets. This is really good. Now, one more question here. Let me hide this one and pull up our next one. And this is really important, again, for what we're about to talk about next. Here's our question. Have you ever had to make a change to your tooling after it was created? So you had that tooling budget we just talked about, you spent it on tooling. Have you ever had to make a change from there? Yes or no? Awesome, we're at about 75% again. Just gonna give it a few more seconds to get our last answers in. Awesome, let's close that up and share it with everyone. Okay, so this is very consistent with another webinar I put on about a month ago around optimizing the product development cycle. And I asked this same question of our engineers there. And actually I had 100% on the last go round say yes to this question. And it looks like we're pretty close to in line with that. So the vast majority of us have experienced that pain point of having to make changes to tooling after it was created and after we had spent our budget on that tooling. So very important here. Let's hide this and hop into why that is important. So let's talk a little bit about the cost to create and the cost to change your tooling, okay? So the cost to create an aluminum tool in the US on average, now realize today, there's a lot of factors that go into cost and lead times of injection molding parts. I think we all know that. So wide range of geometries, sizes, materials, all kinds of things. But again, on average, the cost to create an aluminum tool in the US is going to be a fourth to half the cost of creating a steel tool. In general, aluminum tooling is almost always going to be your most cost-effective option. That is even in my experience when comparing a quote from a China-based vendor for steel tooling to a USA-based aluminum quote. Now, again, there are a lot of vendors out there. I'm speaking on average and definitely through the lens of where I've worked and where I work now. So realize that. The second point here, the cost to change. So we talked about the cost to create. Now we talk about why it matters that you've had to make a change to your tooling in the past. The cost to make a change to aluminum tooling is roughly a tenth of the cost to change a steel tool, regardless of your location of manufacture. So if you make a steel tool in the US, a steel tool in overseas, doesn't matter. It's still going to take, typically speaking, 10 times the cost to make alterations to that tool. The reason for that is that it's going to take much more time and it's going to be much more difficult, physically speaking, to machine steel versus aluminum when changes are required. As we all know, the reason for that is steel is a much harder material than aluminum is. So it's going to take longer and it's going to be a much more difficult process. I'm sorry, I did not mean to jump there. Let's serve another question for our audience here. And that question is going to be, have you ever had to completely scrap a tool and start over from scratch? Okay, we already talked about maybe having to make a change, which is a pain point. Now I want to know if you ever had to completely scrap the tool. The change is not even possible. You got to start over and create a new one. Again, we're at about 75% voting here. I'll give it a couple more seconds. Let these trickle in. Okay, awesome. Let's go ahead and close this up and share the results. Okay, so you can see here about a 60-40 split in favor of no, that you have not had to completely scrap a tool and start over from scratch. But note, those of you who said no to this, that still about 40% of our attendees today have had that experience. And it is very well within the realm of possibility in terms of the molding realm. So keep that in mind as we speak to our next slide a little bit. I'm gonna hide that on top here. So let's talk about, we just talked about the costs, right, to create and change your tooling. What about the time? How long does it take to create an aluminum and a steel tool? And how long does it take to change those tools if you do run into a problem? Okay, so let's first talk about aluminum. The time to create an aluminum tool, and again, on average, is 15 to 25 business days. That's the time it's going to take to create the tool and have your initial T1 samples to either approve or do iterations on if you need to make changes. Which brings us to our next point. The time to change an aluminum tool on average is going to be about 5 to 10 business days. So it's going to set you back a week, maybe 2 weeks at most here to change that aluminum tool, typically speaking. On the other hand, when you're looking at steel, the time to create a steel tool on average is going to be about 35 to 60 business days. Again, in my 2 years of experience of seeing 20 to 40 quotes a day for all of those days across those 2 years, I rarely ever saw a steel tool below that range in terms of lead times, almost never within a month. And the time to change a steel tool as well is an important note here. It's usually going to take you about 20 to 30 business days. So not only is it going to take a couple months to make the tool, if you run into an issue and find at T1 samples a problem or later on even, you're looking at 20 to 30 business days, again, going back to how hard that material is to change your steel tool. Now, a couple of notes you can see here at the bottom. We at Eccentric can create aluminum tools in as few as 5 days. And again, we do also offer steel tooling. One big important note, and this is directly related to the question I asked you before this slide, have you ever had to scrap a tool? Damaged or deformed steel tooling often and easily can lead to the need for a new tool investment, not just a tooling change. So if you have larger changes that need to happen or deformities in the mold over time, that's going to be something that's oftentimes irreversible and not able to be corrected. You may have to just buy a whole new one. And we've already talked about the budget involved there. So that gives you a good idea. Now, let's take a look at our next topic, which you'll kind of get the gist of here with my next polling question. But let's launch that. Let's ask you guys this. How many parts do your molding projects typically require per year? So when you do need tooling and you invest in tooling, how many parts you need per year on average? Awesome, we're right up at around 75%. Give it a few more seconds here for our answers to trickle in. Awesome, let's close this out here. Let's share our results. Okay, so you can see what we have going on here. We've got about a fifth of us need 1,000 parts or less per year on their tooling. About a quarter of us are needing somewhere in the realm of 1,000 to 10,000 parts. Another quarter of us from 10 to 50,000. And some of us as well, as you can see here, are needing the greater volumes. So 50 to 100,000 or more than 100,000 parts per year. Thank you, this was very helpful. And it leads again right into our next topic. So let's talk about your tool life comparison here, okay? So how much volume should you be able to produce with each type of mold? And sorry, I meant to serve one additional question here. So let's go ahead and serve that too. Let's launch this. Okay, so this question here is going to be which best describes when to use an aluminum tool for tooling. For prototyping of fewer than 50 parts, for prototyping of up to 500, for production of up to 5,000, for production of up to 25,000, or for production of up to 100,000 parts per year. Give me some votes here. Tell me what you think. Awesome, and we've got about 70-75% voting here again. So let's get these last couple in over the next 5 seconds and we'll close it up. Awesome, let's go ahead and close this one out. Okay, let's share the results here. Everybody can see what we have. We've got about 5% of folks feel like aluminum is for prototyping with fewer than 50 parts. About a quarter of us feel like it's for prototyping of up to 500. Half of us feel like it's for, could go into production of up to 5,000 parts a year. 13% feel like it could get to production of up to 25,000 parts a year, and 3% of us feel like it could get all the way up to 100,000 parts per year. So this is very good feedback. Let's hide this and hop back in and get our answer. So tool life comparison again. Let's figure out how many parts you can get from each type of tool. So when you're looking at P20 steel tools, which is the type that's going to be defaulted to overseas in China, you're looking at an average tool life of about 50,000 to 100,000 parts, and this is dependent on material used. We'll talk a little bit more about that here in a little bit, but wanted to note that that is material dependent. On the other hand, in the US, again, we're going to default to a QC10 aluminum tool. The average life there is going to be 10,000 to 25,000 parts, again, depending on the material used. So it could be higher, could be lower, just depending on that material. One quick note here that is really important. Excentric guarantees our molds for life, meaning that here we're going to cover the cost of maintenance on your tool or even total tool replacement if it comes to that down the line. So you're never going to have to invest more money to keep your tooling running from wear and tear. And again, when you do need to make changes to aluminum, much easier, quicker, and more cost effective. So that is a good note here. As a result, the answer to our previous question is that it really can be used for up to 100,000 parts per year here at Excentric. That's something that we very commonly see and is definitely within our kind of wheelhouse, if you will. Let's hop into our next topic here and our next question. And that question is going to be, how quickly do you typically need your tooling completed and your T1 samples delivered for approval from the time of your order? Do you need them typically in less than a week? Do you need them in a couple of weeks, maybe 1 to 2? Do you need them between 2 and 4 weeks, typically speaking, 1 to 2 months? Or do you usually have more than 2 months to wait before you need your tooling completed and T1 samples in hand? Awesome, we're at about 70% again. Let's go ahead and get the last couple of votes in and I will close this out. Awesome, okay. Thank you for voting here. Let's share the results. So typically speaking, folks on this call, 5% of us are looking at less than a week for needing tooling and parts. That is very quick. Some of us, about 14%, are looking at 1 to 2 weeks, still pretty quick. 36% of us, 2 to 4 weeks. 41% of us, 1 to 2 months, so you have a little bit of time. And 3% of us are able to wait longer than 2 months for tooling and T1 samples. So, you know, and again, you see a wide variety across different industries, so that makes total sense. That checks out for me. In my experience, you do see a wide range of needs there. But you can see most people falling within that 2 to 4 week time frame, as well as that 1 to 2 month time frame. But you do have some people that need it faster. About 20% of us need it faster than 2 weeks. So let's note that. All right, and let's hide these results and hop back over here. So our next topic is fill flow and cycle time. And you're gonna see really quickly why this is important and why it's related to how quickly you can get your parts in hand. Thermal conductivity of aluminum is 5 times that of steel, okay? We can see as a result of that, many things. So if the metal is more conducive to thermal energy, that means it's going to heat up quicker. It's also going to heat up more evenly across that mold. Secondarily, it's going to cool down much quicker, and it's going to cool down much more evenly across that mold and therefore the part that you're creating within. As a result, plastic material is going to be able to flow longer distances with less injection pressure within an aluminum mold because of that thermal conductivity. Secondarily, aluminum molds are going to fill faster and more evenly, again, because of the evenness of that heat across the mold. 3, parts are going to have minimal warp and much better dimensional stability, giving a higher acceptance rate on parts. The study that we've used actually states that it's about 35 to 40% higher acceptance rates on parts. And number 4, your cycle time is less, and significantly less in some cases, due to the quicker heating and cooling that I just mentioned, meaning faster creation of your parts using aluminum tooling versus steel. So let's really zoom in and focus in for a second on that cycle time. And again, going back to why I asked you that question. If it's taking you, 12 seconds to get a part off the mold versus 21 seconds to get a part off the mold, again, over many parts and moving through the needs that you're going to have, it means you can get parts much quicker. Also, as we spoke about earlier, the tooling itself is created much faster. So not only are you going to have tooling faster, you're going to have samples faster and future part runs faster and more accurate. So knowing that, let's ask you another question and shift gears to yet another topic here that really plays into our discussion. So the question here is going to be, do you often make parts that are highly complex, cosmetic, or where dimensional stability is paramount? Awesome, we're at about 70% again. Let's get the last couple of votes in here and we'll close it out. Great, I'm gonna close this up here and share our results. So it looks like the vast majority of us, almost 90% of the folks on our webinar today do indeed often make parts that are highly complex, cosmetic, or where dimensional stability is paramount. Why does that matter? We just talked about why the dimensional stability matters in terms of the 2 different mold materials you can use, but let's also talk about size and complexity of parts. So aluminum tools will typically offer better results on long, large, or complex parts. Again, it goes back to what we just spoke about in the previous slide. The thermal conductivity of the material is better. The flow rate, therefore, and the fill advantages are also going to be prevalent with aluminum tooling. So you're able to create those long, weird geometries or large geometries and get better fill and flow there. On the other hand, steel tooling is better for parts with very thin features. The reason for that also goes back to some of the things we've already discussed. The strength of steel sometimes goes against it and sometimes operates in its favor. When you need to change or create steel tooling, it takes a while, but when you have parts that have very thin features, the strength of that steel is now a huge asset because it can tolerate much higher pressures than aluminum can since it's a softer metal. The pressure of that injection needed in those thin walls and thin features can, typically speaking, deform an aluminum tool with ease. So that is an area for sure that if you have very thin features on a part, steel tooling is going to perform better for those. Our next slide. So let's talk a little bit about 3 common topics that also are going to play in your decision about which mold you may want to choose. So materials, surface finish, and secondary operations. First, the materials that you can use for tooling, or for making your parts rather, in either tooling scenario is going to be the same. You can run many materials in either one. The exception here, and where steel tooling is going to be the best option due to the above average wear and tear and stress that is put on tooling, you're going to see that exotic materials like Ultem that require very high heat are going to be best for steel. You'll also see that abrasive materials, including high glass fills or other additives, are also going to be much better fits for steel tooling. The reason being, again, it's going to hold up better to that wear and tear. And even if someone does offer a lifetime mold guarantee on an aluminum tool, you don't want to have to be replacing that every couple thousand parts. It's not going to be very conducive to you getting those parts quickly. So again, that is definitely a scenario. If you have exotic high heat materials or abrasive materials, that steel tooling is certainly going to be the better option. In terms of surface finishes, so this is a really interesting topic. The typical standard in the industry is the SPI scale. You also have mold texture finishes, abbreviated MT, that you'll see. The same options, again, typically speaking, are going to be available in either tooling scenario with one pretty special note. SPI A1 as a finish. So that is the highest level of polish. It is an optical clarity that is used very often in medical device and those kinds of equipments. You do need special facilities and or equipment to achieve that level of finish. It takes a ton of polishing. And one thing to note about the finish scale is you must go in order. So it goes from A all the way to D, and you have to start with a D finish, then polish it down to a C, then a B, then an A, all the way down. So SPI A1 is incredibly hard to achieve. And additionally, finish and clarity is much more reliant on the material that you choose versus, in terms of your plastic parts that is, versus the material of your mold. The reason for that is some materials are not capable of achieving an optically clear finish no matter the level of polish you use. And that is typically speaking because the natural color of that resin or that material is just not going to be able to get to that point. It's going to be fuzzy. So that's one important note there on surface finish. And then secondary operations. So, whether you want to ultrasonically weld parts together for assembly, or you need to do additional, threading or tapping after you mold your parts, whatever that looks like, the same secondary operations are going to be available for your parts after tooling, regardless of your tooling material choice. After all, either one creates a plastic part, right? So that is a special note there. Let's serve kind of a finishing almost question for us, and it's going to look a little bit familiar, but a little different, okay? So let's launch this. Our question here is going to be, how many of those original common beliefs that we addressed, right? There were 6 of them. How many of those do we think are correct after covering the material that we did today? The options for you are 1, 3, 5, all, or none. This one's taking a bit longer for answers. I know this is a little bit more critical thinking question, so definitely give you a little more time here. Give you 5 more seconds. Just get your last answers in here, and don't be afraid. I understand. Obviously, we covered a lot of material, so don't want you to feel like, oh, I don't want to put an answer in because it may be wrong. That's okay. Awesome. I'm going to close this out. Let's take a look at our results here. Awesome. So we had a quarter of us that says one of these things was accurate that we spoke about originally. 30% of us, about a third, say 3 of them are still true after what we've talked about today. 5% of us say 5 of them are true. 12% say all are still true. And 26, another quarter of us say none of them are true. So I apologize because it was a bit of a trick question, and actually a little over half of us are correct here. So good work to those of you who selected 1 or none, and let's walk through and let me explain that. Okay, so let's hide this and hop back into our presentation. So let's revisit these. And earlier I called them common beliefs, but this time I would probably like to call them common misconceptions about steel and aluminum tooling. The first one, aluminum tooling is only for small volumes or prototyping efforts. I think we debunked that one today. We talked about how aluminum tooling is typically speaking going to get you anywhere up to maybe 25,000 parts, typically speaking, sometimes higher. And here internally at Eccentric, we do guarantee those for life. And typically speaking, I would say up to 100,000 parts a year is no problem. So that is not prototyping. That is most certainly not small volumes. I would say this one is debunked. Second, steel tooling is the best option if you're looking at moving your project to production. Again, we spoke in this previous point that you can go all the way to production, most certainly with aluminum tooling, depending on what production means to you. So if your production looks like more than 100,000 parts, steel tooling definitely may be the best option. If, however, you're looking at less than 100,000 parts a year and that still means production for you and your business, then aluminum tooling, in my experience, is going to be your best option. So I would say this one, as an absolute statement that it's always the best option when moving to production, is false. Third, Steel tooling produces a part of superior quality when compared to aluminum tooling. We debunked that in the fill, flow, and thermal conductivity slide pretty thoroughly. At the end of the day, steel tooling is going to take longer to heat up and cool down. It's going to do so less evenly, and you're going to run into less dimensional stability, as well as more blemishes and problems with warp and sink and things of that nature. So this one has been debunked. Next, steel tooling can produce geometries and parts that aluminum tooling can't. Here was the trick question. So the answer is yes and no. The answer, again, we go a couple slides back, and steel tooling can produce very thin wall geometries that aluminum tooling typically can't. So that's where I say, yes, this is somewhat true. Where I say it is kind of a misconception is that there are also many scenarios like we discussed, large, complex, things like that, where aluminum is going to have the edge in terms of producing those geometries. So this is both true and false. Aluminum tooling can't produce parts as quickly as steel tooling in a production setting. Again, going back to that cycle time slide where we highlighted cycle times of aluminum tooling versus steel tooling, we're looking at a pretty big discrepancy between how fast you can get parts off an aluminum tool versus steel in favor of aluminum. So this one is debunked. Last but not least, the location you choose for creating your tooling is not a factor in which type of tooling would be used. We debunked that one right out of the gate by saying, obviously in the US, aluminum's cheaper. In China, steel is cheaper. So you're typically going to see different tooling materials based on the location of manufacture. Awesome. Okay, so let's get down to what I promised you, right? I told you I would tell you today pretty definitively when you should use each type of tooling. So when should you use aluminum tooling? If your project requires 100,000 parts per year or less. Again, this is definitely dependent on your partner. This is specific a little bit to eccentric, so I will acknowledge that. Depending on your partner or who you may be working with, that number may be a little bit lower, but for us and partnering with us specifically, for sure, aluminum is the right choice for projects requiring up to 100,000 parts per year or less. If your parts are long, complex, or otherwise a challenge to fill properly, aluminum is the advantage. If your parts require the best dimensional stability and the least cosmetic defects possible, if your budget requires a lower upfront cost, if you need the tooling quickly, because as we remember, if you need tooling within a month, steel almost isn't even an option for you. If your budget and timing don't have large amounts of added wiggle room for mistakes or changes, as we saw, it can be pretty costly and time consuming to make those changes with steel. If you need the ability to order additional parts from the tool in a turnkey fashion, again, going back to the lower cycle times with aluminum, meaning faster parts in your hand. If you anticipate changes to your design in the future, as it's going to be hard, sometimes impossible, and definitely costly and time consuming with steel. If you need to stay in the USA on your project, if you have ITAR requirements, things like that, that's a reason that you would want to stay in the US and therefore would use aluminum tooling. Now, when should you use steel tooling? Because again, a lot of folks out there offer both. Both are very valid options and both have their place. You should use steel tooling if your project requires 100,000 parts per year or more. If you need a very high tool life, definitely go with steel. If your parts have features that are extremely thin and therefore there will be thin portions of the tooling, you should use steel. If your part's incredibly simple, like a poker chip, something like that, where there's little to no chance you're ever going to make changes to your design, steel is a great choice because, again, you're going to be making a very high volume of those guys and you're not going to need to make changes. If your part is made of a highly abrasive or an exotic and high heat needed material, definitely use steel tooling. And if you have a preference to source the parts or the mold specifically overseas and from China, it doesn't make sense in that case to go with aluminum tooling. So steel is going to be the best option. Now, given our discussion today, I'm gonna conclude with a final question, and there is absolutely no wrong answer to this. I just want to know kind of where you're at based on what we just discussed, when both are the correct fit. So answer this for me if you don't mind. It's the last thing I'll ask from you, I promise. Given our discussion today, which type of tooling do you think is generally going to be the best fit for your organization? And again, there's no wrong answers. It's okay if the answer is steel. It's okay if the answer is aluminum. But which one? Which one would typically meet your needs most completely? Awesome, we're at 70%. Give it a couple more minutes here, or sorry, seconds. Awesome, I'm gonna close this up and share the results. Okay, so 65% of us here on the webinar today feel like aluminum tooling would meet most of your needs most adequately, and 35% of us feel like steel tooling would meet most of your needs most adequately. And that's awesome, guys. It doesn't matter what the answer is here. As I've covered today, both are going to be good options for different cases. And again, I've worked across many projects for both. So definitely want to say that both are very valid and good options. And either way you need to go, I just wanted you to be a bit more informed and feel a little bit more confident the next time that you are looking at a project and trying to discern which one would be the best fit. So with that, I'm going to close up and turn us back over to Mark for some Q&A. Thank you, everybody.
Thanks, Taylor. So I just want to remind everyone to please use the questions panel to ask your questions, and we will get through as many of them as we can. And if we run out of time, we'll make sure that we include questions and answers in the follow-up email that we're going to send out to everybody. So Taylor, we have our first question. Actually, it's more of a comment. Scott wanted us to make sure that we knew that he had actually checked none in your first poll question, because he said that all of them were incorrect. And as we saw, that was true.
Scott, what's up, my guy? I'm very proud. You are a true sensei, and maybe you didn't need this material today, but good for you. Very awesome, man.
Our next question came in. Question was regarding lead time, a 5-day lead time for aluminum tool. Is that extra cost?
Yeah, that's a really good question. So our standard lead times, and typically speaking across the industry, your standard lead times, again, will be maybe 15, 25 business days for one of those aluminum tools. Here internally, like I mentioned, we can be as fast as 5 business days. We do have 2 expedite options that are standard here internally. So, usually your average is going to be a 15 day lead time standard. And then you can expedite that one level for an additional cost to be about 5 days faster, and then you can expedite it one more time on some of those projects that obviously it is feasible or possible to create the tool given its size, complexity, etc. In that amount of time. We do offer a double expedite all the way down to that 5-day level. The answer is yes, there is a slight expedite fee, but it's actually not anywhere as wild as you would think it would be.
All right, our next question is, how long is for life? How many parts? I think this is with regard to the mold guarantee, lifetime mold guarantee.
Yeah, absolutely. The answer is truly infinity. With us, it really depends on who you're working with. So different partners may have different, definitions of that. For us, we are going to create the tooling for you and run the parts here on site. You're going to own that tool, and we are more than happy, like I said, to continue to maintain and even completely replace that tool as it experiences typical wear and tear from you running parts. So truly the answer is the limit does not exist.
Just a slight caveat on that is that it's maintained and held by us, and we'll do what we need to make sure it continues to function well, as long as there's additional parts ordered within any given 2-year period. Outside of that, we'll be contacting you to find out what you'd like to do with your mold.
Very good point.
Next question. Are there other cost or logistics factors that can play into the US versus China discussion?
Wow, that's a very good question. I would say immediately yes. When you're talking about bringing over either tooling or parts from somewhere like China, there's going to be a lot of additional cost and logistics involved. You're looking at tariffs, you're looking at import-export type of paperwork and documentation. You're looking at trying to communicate with somebody who's on a 12-hour time difference from you, oftentimes in a different language. So I would say those are definitely all cost and logistic factors, as well as shipping. When you ship from China or overseas, you typically have 2 options. One is going to be boat, which is going to take 4 to 6 weeks at minimum, and is going to be the most cost-effective option. And then your other option is air, which is going to be very quick, but very costly. So that's kind of the cost and logistics additional factors that may play into that discussion.
Okay. I think similarly, the cost of raw materials often fluctuates. Do you ever see times when the USA and China dynamic changes in terms of steel and aluminum?
I have not. It typically is going to stay. Yes, it fluctuates. All markets fluctuate as we know. In terms of these materials, they're pretty big price discrepancies in those two countries specifically, and I have never seen them get even very close to reversing that dynamic in either location.
Okay. Next question was how many folks are watching this webinar? I'm guessing that's to understand the polling questions. We had 87 people at max who were attending. Right now, we still have 72 people online. Next question. I've heard the term bridge tooling. What does that refer to?
Yeah, that's a really good question, and it's very relevant to this topic today. Bridge tooling is what people call tooling that you're going to use before you go into massive scale. So typically speaking, bridge tooling is going to refer to an aluminum tool, and the reason it's called bridge tooling is it kind of bridges the gap between your prototyping and your all the way at massive scales, again, above maybe 100,000 parts per year, maybe you're making millions. But as we spoke about, steel tooling is going to take a long time to get up and running and a long time to get you those parts. So in the meantime, you need a bridge, so to speak, that gets you to market and gets you in front of your customer and starts fulfilling the demand that you have and bridges the gap until you're able to get that steel tool up and running and producing parts for the long term.
Okay, great. Next question. I think we've got time for two more questions, Taylor. Okay. Is the information that you presented today specific to Eccentric, or does it apply across the board?
Yeah, that's a really good question. So some of both. I think I was very careful to note the content presented in terms of if it was specific to Eccentric or if it was more industry. But for the most part, almost all of the material we presented today is applicable across the board. Again, there are so many factors in terms of individual projects and your needs on those projects that are going to go into this decision, as we talked about. But typically speaking, what we've discussed today is going to apply across the board and help guide you in a very true way.
Okay. We've had a ton of questions come in that we're not going to be able to get to all of them, but we will answer all of these and send them out, as I said a few minutes ago, in the follow-up email. But there is one I think that's probably material to everybody. What do I do if I'm working on a project and the right tooling material is still in question for me, even after watching this presentation?
Yeah, absolutely. And that is a very valid and very good question, because at the end of the day, as we discussed, this is a high level discussion that we had today. This was not specific to any certain part or any certain project. So it still may be very tough to know based on the different criteria I gave you. Maybe you have some overlapping criteria that point to each one being a good resource for the project. If you have those scenarios, always feel free to reach out to us or your partners. We're always happy to help to answer those questions. As Mark said, we're going to do our best to answer the questions that have already been submitted here, but inevitably more will come up. You'll have projects in the future. Reach out to myself, reach out to my team here at Eccentric, and we're always going to be happy to spend time with you on the phone, talking and consulting specifically about your project and what's going to be the right fit for you.
All right, well, thanks, Taylor. This has been really a very informative webinar. I want to thank everyone for attending today. We will be sending out a link to the recording of the webinar within 48 hours. We will include the slides and we will include the questions and answers that we were not able to get to. If you have any questions about the topic presented today, you can feel free to email us at info@eccentricmold.com. And also be sure to follow us on LinkedIn so that you can get updates on our future webinars and blogs. Have a great day, everybody.